Hello everyone, my name is Rian Chaudhary and I'm going to be taking you through our PowerPoint presentation for our project, which is a attack surface management project. And this project is designed to automate the process of discovering and managing vulnerabilities or threats that you might come across in your internal network. It's something that's normally done by a lot of cybersecurity teams, but some of them do it manually. Some have automations, and this will show you an automated one using Google Cloud and Python scripts, and we're going to be integrating it into the cloud and then visualizing it. So as a part of the overview, as I mentioned before, it's attack surface management. Hello everyone, my name is Rian Chaudhary and I'm going to be going over our attack surface management project for our class. So a little bit of the overview. The attack surface management project, the process of continuously discovering and monitoring all digital assets that could be targeted by attackers. This project will basically be designed to discover and manage vulnerabilities across networks and threats, and it identifies and exposes those threats, and you'll be able to see the data and visualize it. And a lot of cybersecurity companies do this manually. So our project integrates Nmap, OpenBAS, Python, and Google Cloud for analysis and visualization, and the goal is to deliver real-time visibility and security risks and attack surface trends. So the goals of our project is to identify and track vulnerabilities across network systems, reduce attack surface by centralizing the scan results, and focus on automation, normalization, and cloud-based analysis. And we'll do that automation through our scripts on Kali Linux, and also the cloud-based analysis that you'll be able to see later in the video. So as you mentioned, some of the tools that we use for this is OpenBAS and GVM, so that does the vulnerability scanning, Python for parsing, normalization, automation scripts, and for the Google Cloud storage, that's where we're going to basically be placing all of our scans after they happen into the cloud, and we're going to be connecting that with BigQuery, and you're going to be able to see some of the data that's analyzed on that on Looker Studio. And we did this in our runtime environment on Kali Linux. So some of our key requirements are that the process latest OpenBAS XML scan and normalized to structured CSV. So that was also done doing one of our scripts, which we're going to demo again later in the video. Orchestrate normalization, cloud upload, and optional DB ingestion. Also all done with scripts that we're going to see later in the video. Authenticate with Google Cloud via service account. We were able to achieve that. We did run into an issue with that, but we were able to get that resolved when pushing our project to GitHub. Handle missing data and large scans without crashing. So it's able to handle errors and large scans without crashing, and if there is an error, it will throw out an error message or it just will not scan. But this script was able to seamlessly integrate within the environment and push it to Google Cloud. And also keep credentials and cloud data secure. Because it is on Google Cloud, all of the data is secure. So some of our challenges that we assumed is, requiring authorized target VM and analyst familiarity, hardware and resource limits like CPU, RAM, OpenBAS intensity, assuming stable network and minimal firewall interference, and assuming working setup of OpenBAS, Python, Google Cloud Service, BigQuery, and Kali. So we did run into some issues. Some of our scans took a lot longer, and after allocating more RAM and CPU to it, it did go quicker. We had some issues when setting up the actual virtual machine with our network, but we had to wrap around that by reinstalling a different version of Kali Linux. And some of these things, like on Google Cloud, become a little complex because there's so many different variables when it comes to it. But after tweaking with it a little bit, we got it to work. So for our version control, GitHub is used to track scripts, scans, and documentation. Incremental commits for each module, scan, normalize, upload, and visualize, and version history shows evolution from basic scans to full pipeline. And now I'm going to go ahead and demo our project. Thank you. Hey everyone, my name is Rian Chowdhury, and this is our project for our capstone class for CS 4850. So this project is called SP-101 Green Attack Surface Management. It pretty much stands for Automated Attack Surface Management, and this project is designed to automate the process of discovering and managing vulnerabilities across a network, something that's normally done manually by cybersecurity teams. So I'm going to walk you through some of the setup, some of the Python scripts that we built out, the Google Cloud integration, and how everything runs together in a single pipeline. So right here is our GitHub repo page, and everything is uploaded into this page. You can see all the scripts, our scan runs that we have. There's a README file, and then this connects to our Google key, which lets us upload everything into Google. So everything in this project was built and tested in Kali Linux, which is a Debian-based security operating system. And we used Greenbone Open VAS as the main vulnerability scanner. That's the tool responsible for performing network scans, detecting open ports, and identifying vulnerabilities through CVEs. On top of that, we use Python 3 for automation and Google Cloud for data storage and analytics. So the project combines cybersecurity scanning tools with cloud data visualization tools, which is basically how modern attack surface management systems operate. So right here, this is our Greenbone environment. And you can see different tasks that we can come up with. So for example, we can go into configuration and we can create a new target. And so if we were to create a new target to test for any vulnerability or security issues on the network, we can name the target something like test target. And we would just hit save from here after inputting our host, which would be the IP that is for your specific environment. But just for the purpose of this demo, I already created something before because it takes quite a while to actually run through all the scans because it is a really big scan. So we're going to be using this ASM one that we have. So after you create this test, you can go back into scan, and right here you would click the start button and it would put it into a queue and it would begin to scan. And then once it's done, you are actually able to take this, go into the reports section, click onto the scan, and you're going to be able to download it. It's done scanning. You can download it here as an XML file. And you can do this for whichever environment that you're using. Like, for example, there's another one that we use as an example, which is Juice Shop, but we're using Greenbone in this case. And then once it downloads in your virtual machine or wherever you're hosting this environment, you can come into your Kali machine and you can actually go ahead and enter in this code. So this will pretty much pull the report from downloads and put it into our file trajectory for our coding environment. And what this code is going to be doing is it will pretty much parse through the XML and it's going to convert everything into a CSV. So now now that we have our XML file uploaded into our project directory, we are going to be talking about some of the scripts. So the first one we're going to be talking about is create open vast targets. And this one automates the process of creating scan targets and running scans through the Greenbone API. Instead of actually manually clicking through the interface every time, the script can do that automatically in the background. The next script we're going to be talking about is normalize results. So this one reads the XML file that the Greenbone environment exports after a scan and parses it into a clean, standardized CSV file. It extracts the host port, the host, the port, the severity, the CVE ID, and the description from each vulnerability. And then there are two cloud upload scripts, which is going to be upload to GS and upload to BigQuery Py. These push the normalized CSV files into Google Cloud Storage and then import them into BigQuery for a structured analysis. So we are going to use one of our scripts that we wrote. And what this is pretty much doing is taking that XML file, it's going to normalize the CSV. Now we're going to be running one of the scripts that we wrote to do some of these. So this one went ahead and parsed through the XML and normalized the CSV. And we're going to go ahead and check. So yes, so this one did work. So it was able to go ahead and convert the XML file into a CSV because we have host, port, severity, name, description showing up right here. So what this pretty much did was it took the XML file and it basically parsed everything properly, and it read the XML file, parsed everything into a clean, standardized CSV, then it uploaded it into Google Cloud Storage, and everything was successful from what we can see. So after this gets uploaded into Google Cloud, we're going to go into Google Cloud, and here is where our environment is. So once things get uploaded, we're going to be able to access them from the cloud. So we can go ahead and go over to our cloud storage, click on our buckets, and it's something that we set up earlier, but when we click into our results, you're going to be able to see that this one was just uploaded. So you can see our past test runs. So once this gets uploaded, we're going to go back and we're going to go into a data set. In the data set, we can create a table. And the way you do it is you click onto this, you click create table, and you can choose the CSV file that was converted from an XML file using Kali Linux that automatically got uploaded, and you can just pick whichever one was the most recent one or whatever you named it to be, and it will automatically partition. Everything is automatic, and then once you have this ready, you can click save at the bottom and you're good to go. So we already set one up before, and we have SQL scripts that we can go ahead and run that you'll be able to see how it all looks and how it all works. So once we have our table uploaded, we're going to go ahead and run some SQL scripts. So this specific script right here is going to give you one of many things that you can do. So this one's going to basically just count some of the vulnerabilities by the severity. It'll show how many issues that are like high, medium, low, or whatever is within that specific test run. So we're going to go ahead and run this. So from here, you can see that there are two results, right? Being there's 6 medium and 2 low. Another script that we can run as an example, this one is going to be counting the vulnerabilities per host, and it's going to see which hosts are at most risk. So we're going to go ahead and just put that in here. And you can see which one of our hosts are the most vulnerable and which one of them are at most risk and how many vulnerabilities they actually have. So as an example, the way we can go ahead and graph this is we can open it up in Looker Studio. And you're able to see a dashboard or a report of whatever you scanned from your environment. For example, we used Greenbone. Then we took it into our Kali environment. From our Kali environment, we were able to extract data converted from an XML to a CSV, and then you can come to a place like Google Studio. You can have SQL scripts, and you can see all the data, all the vulnerabilities, which hosts are, vulnerable, and you're able to see all this data, and you can customize these charts the way you see fit. So just as a quick recap, I tested the entire system in stages. First, I ran the Greenbone scans on multiple targets to generate XML reports. Then I ran Python scripts to parse and normalize the data. Finally, we verified that the data showed up correctly in Google Cloud and BigQuery, which it did. And then from there, we were able to demonstrate a working prototype of an automated attack surface management process. And the system worked end to end, from getting the data, from scanning, getting the data, all the way to visualization without really any manual steps. It's a simple, you upload it, you have one script in there, you already have your SQL scripts ready, but just for the purpose of the demo, we just input it just to go step by step, and you're able to see everything. And the result was a working ASM prototype. It automatically scans, processes, uploads, and visualizes vulnerabilities with really no manual steps. And this same setup could be extended to larger networks or integrated into enterprise SOC systems. And it shows how automation and cloud analytics can simplify cybersecurity operations and make vulnerability management faster and more accurate. In conclusion, this was able to demonstrate a modern attack surface management pipeline, and that it can be automated using open source tools and cloud technology. Everything was developed and tested in Kali Linux, integrated with Greenbone, and visualized through Google Cloud. Thank you so much